Alright, what's up guys? This is Probability by Pitman, Chapter 3, Section 2 review section, or sorry, Chapter 3 review, Section number 2, problem number 9. Okay, so let x and y be, okay, that was weird. Okay, let x and y be two independent indicator random variables with p of x equals 1 and p of x equals 1 equals p, and p of y equals 1 equals r. Find e of x minus y squared, which is within the expected value. So the expected value of that in terms of p and r. Okay, so my first thought was, oh, let's use the variance formula, which is variance of x minus y would be, or x minus y squared is equal to, variance of x minus y is equal to e of x minus y squared minus e of x minus y squared. And then manipulating it to get e of x minus y squared is equal to e of x minus y, all of that squared minus the variance of x minus y. But then, since we don't really know what type of distribution this is, we can't really calculate the variance of x minus y despite knowing that they're independent. We should have made it pretty easy because you could use linearity since they're independent for variance. So the only other alternative we can really use is the definition. So let's quickly come up with all possible realities for us to use under the definition. So actually let's write out what the definition even is. So it'll be I equals 0 up to 2. Sorry, no, it'd be up to 1. And remember, so the realities are for x minus y, where remember, because x and y are indicator variables, so x and y can be 1 or they can be 0 with probability p and r, and then the complements of each of those for 0. So let's first figure this out. So 0, okay, so and then this would be I times p of I, sorry. So that's the definition. So let's do this. So 0, which means x minus y equals 0. You write that, and then the probability of getting 0, there are two ways to get it. If we do 0 minus 0, so x equals 0, y equals 0, so 0 minus 0, or x equals 1, y equals 1, so 1 minus 1. Because remember, we're doing x minus y. So those are two probabilities we can use. So the probability of getting 0, 0, where x and y are equal to 0, is just p complement times r complement. So I'll write it like that. And then the other way is if x is equal to 1 and y is equal to 1. Remember, they're independent, so all we have to do is multiply p and r. Alright, that's our 0 portion. And honestly, this is just to show like how it works, because it's just going to be equal to 0 in the end. 1 times, and then there are two ways to get 1. If x equals 1 and y equals 0, or y equals 1 and x equals 0. So this is slightly more interesting. So if x equals 1, we have probability p. If y equals 0, we have r complement. And then if y equals 1, and x equals 0, we have p complement and then r. And boom, we have our answer. So our answer just ends up being p, for our expected value of x minus y, it just ends up being p times r complement plus p complement times r complement. And boom, that's our answer we know. Alright, thanks for watching, and I hope that helped.